Hello, everyone. We are the Autopilot dashboard team going to be presenting on our third sprint. So IBM's Autopilot is a Kubernetes native daemon that continuously monitors and evaluates GPUs, network and storage health, and is designed to detect and report infrastructure level issues during the lifetime of AI workloads. And our vision for our Autopilot dashboard is to develop a fully functional UI dashboard for the Autopilot integrated with the GPU-equipped OpenShift Kubernetes cluster that'll allow for administrators to monitor cluster status, initiate health check tests, and view real-time results within an embedded terminal window. So let's get started with our testing page. We recently changed our MUI components into IBM's Carbon React components. And as you can see here, we added some new features. Like in the sidebar, we have IBM's official logo, as well as some nice headers for the testing page. And also on the terminal, there is now a copy button, which you can use to copy the contents in the terminal.
The terminal also has an expand button, which opens up a modal and expands the test results box. In terms of the test parameters control panel, we added a couple new inputs, such as selecting nodes by the job and also selecting nodes by node label, in addition to selecting nodes by ID. And of course, as Ryan mentioned, all of these are now Carbon components rather than MUI components. So here we see we select some tests. We select the DCGM and PCIBW test. The DCGM has an additional parameter associated with that, which we added in this sprint. It's called the DCGM R value. We're also able to select nodes by ID as previously, but we can also select nodes by job and node label. So here I've opened my terminal and I've given a fake label called test label equals not two for kind worker 1 and kind worker 3. And here I put in the node label, key equals value, test label equals not two. And here on the right, we see that Autopilot gets that parameter and it only executes the tests on kind worker 1 and 3, the ones that have that actual label associated with it. We also expand the embedded terminal window box to get a bigger view, and we use the copy to clipboard button if we want to paste it on a text file, as we see here. Functionality works.
For the monitoring page, we also implemented the IBM Carbon React to make our styling be consistent and match.
And based on the feedback from the mentors, we removed some information from the main table, which are container runtime version and operating system. Instead, we added more information about the GPU, such as the GPU type and GPU count. And as you can see, when you expand the table, we added another table to display the DCGM level 3 diagnostics. So the reason why is because Autopilot automatically runs health checks on nodes with GPUs, and whenever the node has a failed health label, an extensive tests are automatically executed, and this contains information such as the detailed timestamps about the finished diagnostics and the names of the test that has failed along with its GPU IDs.
For each column, we have a filter that shows a dropdown and shows all the possible features for the column. Like here in the GPU health column, there's the not pass and pass, which are all the possibilities for that specific column. And then we have a search bar that searches through all the features and filters based on the matching results, including the features from the dropdown menu, like the DCGM status and diagnostic information.
And here's a demo video of our monitoring page. And that's what it looks like when you expand the table.
And there's each of the filters, and you can select which filter you want. And then clear all the active filters, as well as search the specific name or any of the other features that you want to search through.
I focused on recreating our old login page using IBM's Carbon design components, and once we get the NERC resources, I plan to implement the OpenShift login in later sprints.
Yes, for this sprint, the team is trying to migrate from the regular Kubernetes API to an extension of this API with the watch query. So what this does is it provides a real-time updates on Kubernetes objects such as nodes, pods, and services, but for our case, it's nodes. And these real-time updates include events such as added, modified, and deleted. The functionality of watch is that it reduces the API request by opening a continuous stream.
We also containerized our web app to deploy on our OpenShift project. For this, we created a Docker file, which is compatible with the limited OpenShift permissions. We also created an Nginx server configuration file. We built the image using Podman, and then we pushed the image to a Quay repo. We then went into the OpenShift project and created a service on the project to host the application by pulling the image from the Quay repo onto the service. And after some trial and error, it worked, and we have the active link for our Sprint 3 progress shown in the slide. We also have it on our README as well.
So here's our burn down chart for our current sprint. As you can see, our burn down chart goes into the negatives because our group mates spended more time than originally planned working on each task. And here is a screenshot for the current sprint. As you can see, we completed most of our tasks except for these two. As mentioned previously, we didn't get access to our NERC cluster, so it wasn't a priority to connect it to the Kubernetes cluster. And for building the image of Autopilot, we currently do not need to make any changes for it, so our mentor said this was not a priority. And here is a screenshot of our backlog.
In terms of challenges encountered with getting our MOC resources and deploying Autopilot on our NERC cluster, of course, as mentioned, there was a delay in setting up the test cluster. And this delay was because the developers working on our issue, on the issue we created for the Autopilot dashboard, they happened to be out of office. So we actually got in contact with MOC early on in the sprint, but we couldn't get access to the resources in this sprint because, of course, the devs were out of office. But we should be getting access later this week. So for Sprint 4, we should be moving forward smoothly with that. We also had some issues configuring the Docker file and Nginx configuration file. Initially, it was working locally, but it wasn't working on the OpenShift project. This was because we failed to account for limited permissions at first, but then we fixed this and resolved it.
Another challenge was to implement the Kubernetes API watch. So unlike traditional APIs where we receive the responses in one go, streaming API sends the data incrementally in chunks, and processing these chunks and maintaining the updates in the same time can be challenging. But the team is able to accomplish this to list the node names, but not yet for other more node details. In terms of the challenge of styling the dashboard, we had the trouble of displaying the DCGM test details because it's based on a very long JSON structure, but this is resolved by clarifying with the mentors.
Another issue we had was formatting all the dropdown menus to fit the text correctly because of different text lengths, and we fixed this by using dynamic sizing. And then when we were using the Carbon React components, since they're similar but don't have the same functionality as the MEY components, we had to read through the documentation to understand the different features and way that the Carbon React components works.
So some lessons learned in terms of containerization. As mentioned, first of all, the container image worked locally initially, but it didn't work on the OpenShift project. And this shows that just because the image deploys locally doesn't mean you can be guaranteed that it's going to work for all remote environments, because different environments have different permissions and access settings. You kind of have to navigate through that. In terms of the delay in getting MOC resources, we also learned to kind of expect delays and work with that and do other work rather than being blocked by it.
For styling, we learned that it's important to have our web page work for different size screens. which we noticed while developing because each of us have different sized screens or computer screens. And then we implemented this using dynamic sizing and relative sizing compared to your screen size rather than fixed sizes.
In terms of feedback we received for containerization, our mentors wanted to add the container image of the Autopilot dashboard to the main Autopilot Helm chart.
Another would be to have a makefile to build a container image of the dashboard, as well as to be careful with resources because GPU are charged by the hour.
In terms of some feedback we got for our testing page, they wanted us to have a feature that allows users to expand the test results and to have a more advanced filtering feature, such as the job name and node labels. But since our meeting with our mentors earlier this week, we were able to implement that before our sprint ended. Steps for our next sprint, we want to address feedback points from the previous slide and continue to work on the Kubernetes Watch API to display more node information. And hopefully we'll get our access to the NERC cluster. So we will set up a test cluster on NERC to run Autopilot and host the dashboard, and then deploy Autopilot and the dashboard to the NERC cluster, where we will then perform extensive testing and refinement, and then hopefully get the OpenShift authentication to the cluster. Thank you.
Yay!